Okay, good afternoon. I'm going to show you this work that is oscillatory ethanol extraction by evaporation from a membrane bioreactor. This is the structure of the presentation. First, we're going to see the introduction. In this point, we're going to speak about the problem and the possible solution. Then we're going to speak about the membrane configuration, then the per-evaporation experiment, and finally about the fermentation integration and per-evaporation. And in the last part of the presentation, we're going to show the conclusion of the work. First, we need to speak about how we can manufacture ethanol. Okay? The process have three main steps. Okay? The first step is fermentation. We take mainly water and sugar, and we make the fermentation, and we obtain ethanol water mainly. In this we pass to the second step, in the step of distillation, and we finally we take the purification step, and we obtain the ethanol in high purity. And what is the problem? The ethanol have a high market. In all the country, the cars have ethanol in his fuel, and this process have a high energy requirement, and in the step of fermentation have high production inhibition. This means that in this point we only can get a 10% of concentration of ethanol, okay, because it's the top of the microorganism. I don't know, excuse me. But the reason we have in the process high water requirement, because we have the product in a low concentration, and we have a high investment cost. What is the possible solution to this problem? We can integrate these two steps only in one step. How? We can put inside the fermentation one membrane, yes, in a process that called per-evaporation. In this process, we put the membrane, and the membrane only allow the pass of the ethanol, yes. And then we put the fermentation, put the membrane inside the fermentation, and then the stream of the per-evaporation go to the purification, and we only need 2 steps, not 3. We can get a low energy requirement, and we can get a better production. Okay, we see all this explanation in a last presentation. Okay, thank you. This is the membrane configuration. We manufacture the membrane in our labs. And how is this membrane? In green, we can see the ceramic support. Okay, you buy the ceramic support in a company. Okay, and then you make a deep coating, and you put the other layers over the ceramic support. Okay, over the ceramic support we put a gamma lumina support. This layer give strength, mechanical effort, yes, okay. And finally, the PDMS layer is allow the separation of the ethanol and water, okay. Thank you. Okay, how we can test these membranes? We have a vat, and this vat allow the temperature constant in the experiment. The vat pass the stream to the membrane and go back to the vat. Okay, and in this part of the membrane module, we have vacuum pump, and we make a guide force that can allow test the membrane. Okay. This is the mathematical model of the flux of the water and the ethanol through the membrane. We can see in the this part that this is a particular expression of this mathematical model, because this show to the people that work in this work that the water have a power over the ethanol. Okay, if more water pass through the membrane, arrastra, I don't know.
Leaves? No.
Drop? Yes. Drop more ethanol. Okay. We test many membranes in this work, but I want to show all the better membranes. Finally, we need a membrane that have more selectivity and more ethanol permeation. We evaluate all the membranes, and we conclude that we're going to work with this membrane, PDMS5, because was the membrane with high selectivity. All these membranes have a different technique of manufacture, okay? And this techniques was proposed by the work, but okay. We take this membrane and we test the membrane in a different temperatures and mass fraction of ethanol, okay? This is the behavior of water flux and the ethanol flux. With this point, we test the mathematical model and we minimize this constant. We can see in this constant that these two kind of membranes, a bad membranes and a good membranes, have only one difference in his constant, and was the constant of drip of water. Okay, is the only difference between the two membranes. Okay, and finally, this is a behavior of our membrane comparative with other membranes in the literature. Okay, this is a typical PDMS membrane. This is our results. Is better result than the typical membrane results, but we find in the literature that if we combine PDMS with blends of zeolites, we can get a better performance, but we only make this work to this point. Pure PDMS. Okay, in this point we have one question. How can function this membrane inside the reactor? We take the mathematical model and we put the mathematical model of the typical fermentation, and we make a simulation about the behavior of the fermentation integrate with the membrane. This is the mathematical model. We can see that this is a typical behavior of CSTR reactor, but this have one difference, because have one extra term that is the flux through the membrane, but in the product ethanol and in the water, okay, because the membrane allow the pass of these two components. This is well, we make the simulation and we can see that if we use a conventional fermenter have a stationary behavior, okay, but in integrate reactor we have a problem because if we use a exact value of relative area, we have a continuous behavior. But if we use a low relative area, we have a problem because the mass inside the reactor grow indefinitely, yes. But we have other problem that if we use a high relative area, we're going to have an empty reactor in the time, okay? And for we don't have problem with the mass fraction in the ethanol removed, okay? This is not a problem, okay? Okay, this is the purpose that we can make an oscillatory system. How can make this process? We use a high relative area and we can turn on and turn off the membrane. In this form we can get a continuous system, yes. But this is the reason because the reactor is oscillatory. This is the only reason, okay. This is the finally results. The first, we test all the systems in the same condition, but we can see that we can remove more ethanol with hybrid systems, okay? We can more mass fraction with integrated system. We have a less energetic consumption with the hybrid system. But only the oscillatory system can give us a steady state operation, okay? But the reason the oscillatory system is the best system in an integrated system of bioreactor and evaporation, okay? This is the conclusion of the work. The membranes have high permeability and normal separation factor. Oscillatory and continuous reactor produce greater amounts of ethanol per reactor volume and higher purity of ethanol produced than conventional fermentation. The energy consumption evaluate established that to obtain ethanol from CFPS or OFPS is 35% lower than required by conventional fermentation systems. And CPS, like the FPS, not required to maintain an exact ratio of membrane area and feed flow rate to achieve a steady state operation. So the configuration of FPS happens to be the most promising technology. Okay. Thank you. Thank you very much. You have questions? Maybe? Yes.
And do you have show these results to some company in the industry from the ethanol that, or you have checked some aliens or some co-work with other industry, with some company in the industry?
In this moment, no. We work in this topic in Manizales. But the professor was jealous and this is the point that he never want to speak about the results, but it's a mistake because we need more work, because I don't see in the presentation, but this technology have a big problem because the membrane have is have an incompatibility with the fermentation, and the membrane lost in the fermentation, disappear. Okay.
You said once time, just once time, or you can't finish the process.
I prove all the membranes, all the techniques in the fermentation, and all have this problem. But it is not impossible to take this technology and take to the industry. But we need more work, and we need to share this information, and we need more ideas to can fix this problem.
So you're saying that the membranes are destroyed in this process,
Yes, Ken, you're right.
but you're making very significant energy savings.
Yes.
So what's the cost ratio between the energy saving cost and the cost of the membranes?
It's better the membranes, because you only need to pay the membrane one time in 5 years. Yes, but you can get a 35% of lower energetic consume for these 5 years.
Right.
Economically topic is better the use of the membrane, but we need to work in the structure, in a material that can resist the chemical stress.
How much a membrane costs?
This is other problem, but we need more investigation, because in this moment is expensive, but have a tendency in the time that in 5 years is very cheap by a membrane, because all the people that work in membranes know that need to work in a better material for the membranes. But the reason all the time the membranes are more cheap.
Can we see the slide membrane, please? The third, I think that the third.
The third one.
Yes, okay, thank you. Okay, what is the structure, chemical structure for the PDMS? Do you remember exactly or no?
No,
It's a polymer.
it's a polymer, polymethyl siloxane, and you can buy this polymer in a company, but we want to we test another techniques of manufacture. The problem is not the PDMS. You can use the PDMS and other technique of manufacture, and you can improve your results.
What is the role for the gamma?
Gamma lumen.
So,
It's a
the role,
It's
the
a good
function
question.
of this.
Okay, this membrane have a particularity, because when she have a contact with the blend of ethanol and water, she swell. Yes, she
Expands.
She
expands.
Expands. Gets bigger.
And if you don't put this cape of gamma lumina, she expands in the ceramic support
with water, no?
with water or ethanol, with two components. This is a behavior of the membrane.
Okay.
Okay, but if you don't put this layer, you have a problem, because she tried to expand it inside the ceramic support, and this is a problem of flux. But if you put this layer of gamma lumina, the porous is very small, and the membrane can expand in these pores.
For that reason is gamma.
Is gamma. Is the only reason. Yes, but you can use other ceramic support with
For the pore size.
yes, the spore sites. Yes, but this is you can use other support.
But when you prepare this membrane, what is the way to control the thickness, because you need exactly what the thickness is. Okay.
Thickness, yes.
For
Very
this.
good question, Professor. Yes, this is a result of the investigation because this technique is called deep coating. Yes,
Mm.
you take the
Calcination is you require calcination for this.
yes, more or less, yes.
Okay, what temperature for this calcination?
No is calcination, but you can cure.
Okay,
Yes, cure. In 40 degrees.
40 degrees.
Yeah, 40 degrees for 3 hours. This is this cake, this layer
But
of
you
gamma
need
lumina.
prepare- you need prepare the suspension, or call it that suspension for the
Yes.
gamma aluminum.
Yes,
Okay.
for both.
For-
The gamma lumina layer and the MS.
It's a mixture for the.
No.
No? Okay.
You first you take the ceramic support. You buy in a company the ceramic support, and you take the ceramic support. You put the ceramic support inside the solution
into the solution of the
of-
gamma
of the
aluminum.
gamma lumina. Only water and gamma
You
lumina.
require to dry
Yes.
after that.
You dry this layer and you then you calcinate the gamma lumina. The gamma lumina, yes.
Yes.
Then
The
you
layer
have
for this layer.
for the layer you calcinate this layer, but in the next step you take the support, the gamma lumina, and make a deep coating with a solution of PDMS, and when you take this layer you put in a cure in a
Cure.
the cure in a 40 degrees for 3 hours. This is a
This is the process.
this is a process.
Okay,
It's
this
difficult
membrane.
because you take 3 days to make one membrane, but the thickness you can select the thickness with the speed of the remove about the solution.
Yeah.
Yes.
But what is the characterization? You prepare the characterization, for example, for the X or microscopy, electronic
Yes.
microscopy for this.
Yes, this is a same picture.
Scanning electronic.
Scan electronic
Microscopy.
microscopy. Yes, and we have a problem. If you can see that I put a yellow when you need to see the PDMS membrane, but if you take off this, you
This is the
you
special
can see.
color for this.
Yes,
polymer?
but I put the color to show you the
Okay. Okay.
where is the membrane. But
Sí.
we in this work we manufacture membranes with a thickness of nanometers, and the SEM cannot see this membrane. We know that we have a membrane because we have a separation of ethanol and water, but we cannot see the membrane. We can see the gamma alumina.
So the only test is, does it work or not? You can't test it in any way before you put it to work.
Well, okay, we test because we take this membrane and we take 2 pictures. One picture in this form, yes, and we cannot see the membrane, and we move the membrane and we take other picture. Okay. The same have ability that can give to you the composition of the layer. Yes. In this form, we can see the composition of the membrane. We know that we have a membrane. Yes, because the same analysis of composition tell us this information, and because we can see that we have an effect over the process of ethanol and water.
But
If we test the membrane without the layer of PDMS, and we don't have any kind of selectivity.
but you can measure the thickness of the membrane because it is too small.
I try for every form, but I cannot see the thickness. We take all the equipments in Manizales and we take we take the deep coating of PDMS with a big thickness, and we can see this thickness with SEM. And we take other technique that was, we take a 3 speeds of removal of the membrane, and we see with the SEM the thickness of the membrane, and we take a bad expression is a linear expression, okay, with correlation of 1, and we speculate that with this result that the membrane have a thickness of nanometers, but we cannot see the membrane.
Okay. Thank you very much.
At this point, your research is finished, or what is the future work of?
I want to work in the research in the future, but in this moment I change my biofuels. I work in this moment in biodiesel, but I going to work with a membrane. Yes, but it's other kind of research. I want to. I think we have a lot of work to make, but in the future. Thank you. Thank you.
Okay.
I have another question, but